Now, number 6. We want to show that line BD is 9.5. The question says, show that BD is 9.5, correct to 2 dB. So we want to show that this line DB is 9.5. Okay, so you want to show this line DB 9.5. So to do that, so we'll solve for this. It is in a triangle that has that has 2 sides given and 1 angle given. The line we're solving for is opposite the given angle. So therefore, we are going to use cosine rule. We're going to use cosine rule. Now to use cosine rule for this question, DB or BD BD square is 6.5 square plus 10.4 square minus 2 into 6.5 into 10.4 cos angle 64. So this follows cosine rule pattern. Then BD square should give us so this should be 91.14. So BD should be the square root of 91.14, and that should be roots answer. That should be 9.547, approximately 9.55. So 9.55 centimeters for BD. Show that angle BCD, angle at C. BCD is angle at C. Show that angle BCD is 1.112. So now angle BCD is the angle here. We want to show that this, now let's first of all, we've got this one to be 9.55. So want to show that this angle is 122. Now this angle is in a triangle that has 2 other angles given, 26, 42. So just subtract these 2 from 180, you get your angle BCD. So BCD plus 26 degrees plus 42 degrees should be 180 angles in a triangle. BCD plus, add this up, get 68 degrees is 180 degrees. So BCD should be 180 degrees minus 68 degrees, which is 112 degrees. So we know now that this angle should be 112. We know that now. So next thing what to do now is to calculate CD. Line CD is this one here. This is line CD. Okay, line CD. It is facing angle 42, and then what about another side 9.55 facing angle 112. So you can easily apply sine rule to find the angle because side and corresponding angle are involved here. So CD divided by sine 42 is 9.55 divided by sine 112. So CD is 9.55 over sine 112 degree multiplied by sine 42 degree. And then to do this, you're going to get a solution. So the answer should be 6.89. Now, the next part is find the shortest distance from D to AB. Shortest distance from point D to line AB, that should be perpendicular to line AB. So let us look at line AB. This is line AB. We want We want to find distance. First of all, this is 6.89. Then we want to find distance from D to AB. Let's just draw a line making 90 degrees with this line. So consider that once you get this 90 degrees, you can cut out the triangle. Cut out the triangle with line AD facing 90 degrees. You cut it out, it looks like this. 90 degrees, 64 degrees, 6.5 centimeter here. So this is point D, this is point A. You can find this distance. Distance, let me call it H. Distance H. Okay, so distance H. So that H is facing angle 64. And it's a right angle triangle, so you can apply trigonometric ratio. So sine 64 is opposite over hypotenuse. Sine 64 is H over 6.5. So I can say that sine 64 is H over 6.5. So H is now 6.5 multiplying sine 64 degrees. So H should be, you can get it by saying 6.5 times sine 64 degrees. And that is 5.84. 5.84 centimeters. It's already. So that's it. So the next one to look at, okay, now we are done with number 6. We're going to number 7a. This 7a is algebra question. So you have to notice that you can notice that there is variable on the left. So to solve this, we have variable x on the left, variable x on the right. We will collect like terms. So 3x is positive, 4x is negative. Let the negative one move to the positive to meet the one that is positive, so that it too can become positive. 3x, 4x comes here, becomes positive. 6 is on the right. 8 comes across, becomes positive. Add up 7x is 14. X will be 14 divided by 7, 2. So 10a squared plus 5a, what is common? Want to factorize. Between 10 and 5, 5 is a common factor. Between a squared and a is a common factor. So I will divide each of them by the common factor 5a. 5a divided by 5a. Then I'll end up getting 5a outside. 5 cancel 10, I have 2. A cancel a squared, I have a. Plus 1. 5a into 2a plus 1. Factorize this. Now the best way to do this is to look at the fact that this bracket is a square now. And this line is a square. So I'm going to reduce the difference of the squares. So I'm going to have 2x minus 3 squared minus 9 becomes 3 squared. This is similar to having a squared minus b squared, where a is a bracket like this. So which I can say a plus b into a minus b. So in the same way, this bracket plus 3 into this bracket minus 3. So I can say 2x minus 3 plus 3 into 2x minus 3 minus 3. And that should give us 2x into 2x minus 6. This one, 2 can factorize out of this one. So you can have this 2x is here. Now to factorize this one, I can have x and minus 3 if I can factorize 2 out of it. Okay? 2 is common between these two. So these two can multiply this 2x and I can get 4x. Let me write it there, 4x into x minus 3. 4x into x minus 3. Now the next question, f of x is 1 over 4x minus 4 and g of x is 3 by x. Find f of 4. F of 4 is I'll keep 1 here. Anywhere I see x, I'll put 4. 4 into 4 minus 1. That is 1 over 16 minus 1. 1 over 15. Now to solve g of 2, to the power find g of 2, which is anywhere I see x, I'll put 2. So 3 raised to the power 2, taking 9. So g of 2 becomes g of 9, which is 3 raised to the power 9. And 3 raised to the power 9, 3 to the power 9 is 19683. So next one, g of k is f of 7. Yeah, what is g of k? Anywhere I see x here, I'll put k. So this becomes 3 to the power k. F of 7, anywhere I see x here, I'll put 7. 1 over 4 into 7 minus 1. Now, notice that there's a comma here. I should have mentioned this earlier, I'm sorry. This x not equal to 1 over 4 is a kind of a disclaimer. This is the value of x that will make this denominator become 0. And you know, 1 over 0 is math error. So that is why they are keeping the disclaimer. So it doesn't affect the question so far. Just a condition that it becomes undefined if x is equal to 1 over 4. So to solve this, so 3 raised to the power k becomes 1 over 4 times 7 is 28 minus 1, 27. So I kind of have, I have this and I have 3. I can't make this 27 in index form. Since I know that 27 is 3, the base of 27 in index form is 3. 3 to the power k is 1 over 3 raised to the power 3. I can take these 3 to numerator, that will make the power index of the exponent to change sign. 3 to the power k becomes 3 to negative 3. So these 3 and these 3 are the same. The exponent k and minus k should be the same. So k should be negative 3. Next question we're looking at is...
This is what we do in the masterclass, really. We try as much as possible to ensure that we're able to properly, right, teach learners how they can properly understand, interpret the question as much as possible. We dive deeper than just a past paper to ensure that at the end of the day, they're able to fully understand any question that is being administered to them.
A question that will involve graph. A baker decorates a small cake. A baker decorates X small cakes and Y large cakes. In one day, it decorates not more than 16, less than 10, not more than 16 small cakes, less than 10 large cakes, more small cakes than large cakes, a total of not more than 24 cakes. Now, this will give us some equations. One of the inequalities that I showed this solution is this. So that should belong to the first one, x less than or equal to 16. For this one, less than 10 large cakes. So y should be less than 10. This one, more small cakes than large cakes. So the small cakes x are more than the large cakes, or I can say y is less than x. A total of not more than 24, so if I add y plus x, I'll get less than 24. So to write down the other 3 inequality, the first one is y less than 10, the second one is y less than x, then you have y plus x less than 24. This will be our 3 equations. Now, on the grid, draw 4 straight lines and shape the unwanted. Take note, unwanted that should be shaded. So start with the first one given. X is less than or equal to 16. Now, since there is only x in this equation, there is no y, we go to the x-axis and draw a line that can only pass through x. A line that can only pass through x is a vertical line. So we're going to draw a line here. It is double equality. We have x less than or equal to 16. So to be a straight line, we have a line passing going up like this. So you have done that first one. That is the line. Now this line is for x. This line itself is this line is x equal to 16. On the left you have x less than 16. On the right you have x greater than 16. But what do we need? Do we need the region of x less than 16 or less than or equal to 16? So that means that this right side, we don't need this, that's right hand side. Okay, we don't need the right hand side. I'm coming. We don't need this. So the next thing you want to look at, let me remove the equation of this on the graph. Okay, so the next equation is the result of y less than 10. This one is single equality, so to be broken lines or discontinuous lines. So since it's only involving y and y, go to the line, draw a line that involves only y. That should be a horizontal line. So broken lines like this, the broken lines like this. So I'm just cutting the grid. Okay, I'm only cutting the grid. That makes my line more organized. So this line itself is y equal to 10. Above is y less than greater than 10. Below is y less than 10. We need y less than 10, so that means everything above we are removing. Everything above remove. Okay? We have this small rectangle remaining. So the last equation is y plus x less than 24. So if what we do y plus x less than 24, we use the intercepts on the y-axis. X is equal to 0. So you have y less than 24. Before I do this, no, we're going to use the equation y plus x equal to 24. Use y plus x equal to 24. For this, on the y-axis, x is equal to 0, then y is 24. Mark it here. On the x-axis, y is equal to 0, then x is equal to 24. Mark it so you have 24. So you're going to join these two together and you have the equation. So again, I'm marking the grades. It begins like this. I should do this with a ruler, but I don't have a ruler, so let me just do it carefully this way. Broken lines. So now, this line is y plus x equal to 24. The region above. So this line is on. So this is y plus x equal to 24. Above is y plus x less than 24. Below is y plus x. So this is y plus x greater than 24. And below is y plus x less than 24. We need y plus x less than 24, so this region below, so above cancel, so put to cancel this one too. This is cancel, okay? So you can remove all these things and do a proper cancellation. This is just to show you where you're cancelling. Okay, that means that we need, let me say, I like to use what we need. We need only this region shown like this. So this is what we are looking for. Okay? So that means everything else should be cancelled. So then just try to cancel it at 45 degrees to the or positive x-axis. So that and mechanical engineering friends should be proud of us. So there you go. So for calculating all what I've written before is just for to take sake, this is what should be doing, cancel out the region you don't need so that you are only leaving the region you need. Now, this highlight is just for future's sake. Let me remove it. I think it's taking highlights my calculation, my drawing. So now, this is the region I need. To solve for this region I need, okay, I've shaded the region I need. And will I label it R? I'll label the region R. So this is my region R. So the next thing is Lika ends X N. Okay, the profits. And this and the Lika ends $8 for every small cake and $12 for every large cake. Now, this is the diagram to find the largest amount Lika can earn in one day by decorating cakes. So we can say that the earning is each large cake he earns 8, but only small cake is he earns $8. For all the small cake that is 8x. For all the large cakes that is 12y. So the largest earning are always located at the vertices. So we have vertices. Let me change the ink to highlight the vertices. We have vertices here. Then we call it A. That vertex here. But I won't mark this place because at this line you have dotted lines with less than 10. So 9 is the biggest number less than 10. I'll mark 9 as B. We have vertex here, but this involves this continuous line should be less than 10 to 9. I'll mark this place. I'll call it C. So we have vertex here. So I'll mark this place or this place. Then you mark this place because we're already less than this point C. Then you mark this place, I call it B. With this vertex here, I can mark it because it has broken line. I can mark this place, it has straight line. So I mark this place, I call it, sorry. Okay, D, D, this is D, and this is E. So over this here, we call it F. So we can now, along this line, we can only see that the profit is more at B than A, so A can be. Along this line, we can see that the profit is more at E than F, so F can be. Only left with B, C, D, E. Now, along this line, see that on a straight line, C is more than B on the straight line, so B can be. And left with C, D, E. So only point C, D, and E. So point C is 14 by 9. D is 15 by 8. Let's do that. So you have point C, point D, point E. So let me change my ink, sorry. This one is 14 by 9. This one is 15 by 8. It should be 16 by 7. So the highest should be any of these. So at this point we have 8 multiplied value of x 14 plus 9 times value of y. So we times 12 into 9. 12 into 9, 12 into 9, we get 80 plus 2, 112 plus 108, we get 200. 220, I mean, 220. So at this point, we have 8 into 15 plus 12 into 8. We have 120 plus 120, 96. That is 216. At this point, we have 8 into 16 plus 12 into 7. That should be 64 times 2, 138 plus 84. That should be 212. So the highest is at this point C. The highest profit we can make is $220. So you are done with that. The next one to look at is
This is what we do in the masterclass, really. We try as much as possible to ensure that we're able to properly, right, teach learners how they can properly understand, interpret the question as much as possible. We dive deeper than just a past paper to ensure that at the end of the day, they're able to fully understand any question that is being administered to them.
question 9. This question, we have a sector and a part of it is shaded. So you have a small sector cut out, as if you cut out a small sector from a big sector. So find the perimeter of the shaded region. Therefore, which side can we get? The entire of this side is 17. Remove 10, this must be 7. Remaining from here to here should be 7. Also, here to here is 7 also. So the thing you want to do is to look for the 2 arcs. Once you get the 2 arcs, you can find the perimeter in this form. So, how do you find the length of an arc? Arc length is theta over 360 times 2 pi r. So, the small arc then, the angle is 60 over 360 times 2 times 5 times radius is 10. Radius of the small arc is 10 times 10. You end up getting 10 pi over 3. Let me write it here, 10 pi over 3. For the next one, larger arc, the same angle 50 over 360 times 2 times pi times 17. Then I'm getting 17 pi over 3. So the perimeter is 7 plus 7 plus 10 pi over 3 plus 17 pi over 3. This gives us 14 plus 27 pi over 3. 14 plus 9 pi. So we have to write it in the form of a pi plus b. So pi must be what? 9. A must be what? 9, correct. A is 9, b is 14. So we move on from here. B is, this is question 9b. B is an hexagon. Now, the area of the hexagon is 127.3. Show that the length of one side of the hexagon is 7 centimeters. How do we do this? We know that we can. Now let's check what's the value of the angle, interior angle of an hexagon. The exterior angle is 360 over 6, which is 60 degrees. The interior angle must be 180 minus 60 degrees is 120 degrees. So now this angle here is 120 degrees. We can divide this hexagon into 6 by cutting along opposite vertices. Let's try to cut it carefully. So if I cut this, I have 6 triangles. This angle, now, regular hexagon means that all sides will be equal. All sides will be equal. And then the angles, let me cut out one of the angles formed. Now, this angle is 60 because you're positive 2, so this is 60, 60, 60, 60, all the angles inside now are 60. 60 here, 60 here. This line, okay, this one on the side. Now, if this 60 and this 60, what will be the last angle? 180 minus 60 minus 60 is also 60. So all the angles are 60. If all the angles are equal, that means all sides are also equal. That means that all the sides are equal. So what that means is that we can solve it like you are looking for area of an equilateral triangle. So let's say that each side is x. All sides will also be x. So you can find the area of the triangle. Hold on. Now, I say that 6 times the triangle, 8 triangle. So therefore, let's find the area of the triangle. So make it more convenient for us. Area of the triangle is half AB sine theta. Half, the A and B are equal, the same, so I'll say x times sine 60. We do this to get 0.433 x squared. So now that I've got the area of each triangle, can I see that 6 times area of triangle is area of hexagon. So 6 multiplied by 0.433 x squared should give us the 127.3 that is given. So we can say that x squared is 127.3 divided by 6 times 0.433, and that will give us what? So that should give us 48.9992. So x will be the square root of 48.9992. That is approximately 7 centimeters. So I've got that. The hexagon is a cross section of a prism of less 10 and a volume. Volume is area times the particular length, 127.3 times 10, 1273 centimeter cubic meters. Volume of the prison. Calculate the surface area. Now there are two in these surfaces. There are two hexagons. You have two hexagons plus. Now we have some rectangles around. This is a rectangle. How many? There should be six. Since there are six sides for the hexagon, there should be six rectangles plus six rectangles. So therefore, two hexagon, that is 2 into 127.3 plus 6 times rectangle. Rectangle should be then each side is 7 centimeters multiplied by 10. So we are having 254.6 added to 420. So the volume of the surface area of this should be 674.6 centimeters square. Now we have number 10. A is a point. A is the point 6.2 and B is the point 3.4. Find the coordinate of the midpoint. Midpoint will be the average of the coordinates. So mid x is average of 6 and 3. 6 plus 3 over 2, 4.5. 4.5. So mid of y is average of 2 and minus 4. 2 and minus 4 divided by 2 minus 2 over 2 minus 1. That should be -1. Calculate the length. Now, if you're looking for the length of the line, that will follow Pythagoras theorem. So the length of the line is of length is square root of change in x squared plus change in y squared. It should be square root of change in x, 6 minus 3 squared plus change in y, 3 minus 4 squared. Square root of 3 squared plus 6 squared is square root of 45. So the square root of 45 should give us 6.708, 6.708, okay, or 6.71 as the length unit. So you have an equation here. B part, the equation of the line is 4x plus 2y minus 12 is 0. Find the gradients. If you can find the gradients, you can put it in the form of y equal to mx plus c. For y equal to mx plus c, m is gradient. So solve for y. Make y the subject. And 3y is minus 4x plus 12. Y becomes minus 4 over 3x plus 12 over 3, that is 4. So gradients m equal to minus 4 over 3. Now, find the coordinate of the point where L crosses the y-axis. Now, at that point, that is at y intercepts, x should be 0. So y equal to minus 4 over 3 into 0 plus 4. So y should equal to y equal to 4. Now when y is equal to 4, x is 0, right? I put x as 0. Line P is perpendicular to line L and passes through that point. When two lines are perpendicular, their gradients we multiply to give us -1. So gradient of P become M2. So gradient of P M2 multiplied by gradient of line L minus 4/3 should give us -1 is a perpendicular P and L perpendicular. In that case, M2 should be -1 times 3/-4, as presently gets 3/4. So you have y equal to 3/4x plus c. And then you have the points at 6, 5. When x is 6, y is 5. So I put 5 for x. 3/4 into 6 plus c. Now 5 is, this is 4.5 plus c. That means that c is 0.5 or 1/2. So I'm now write this equation. Y is 3/4x plus 1/2. That's really now the next part is calculus question. The point -1,6 lie on a curve. The curve has the derivative function as that. Show that the point -1,6 is a stationary point. Hence, dy dx is equal to 0. So I've got x already, so just equal to 0 -4 over -4x squared -4x cubed minus 9x squared plus 5 when x is 0 equal to 0, I mean. So okay, we want to show that when x is 0 at this point, so when x is -1, when x is -1, I put -1 into the equation, -4 into -1 cubed minus 9 into -1 squared plus 5, -4 into -1 cubed is still -1, -9 into -1 squared is 1 plus 5. This is 4 minus 9 plus 5 equal to 0. Hence, it is a stationary point. Since dy dx is 0, then -1,6 is a stationary point. The next question is, a different curve has the equation that calculate the gradient of tangent to the curve at -2,2. So we're going to do divide x. So y is 2x cubed minus 6x plus 8. Dy dx is 3 times 2 is 6x. 3 minus 1 is 2. Minus 6x goes. So now, what to look for the gradient when this is the gradient function, dy x. So when x is -2, when x equal to -2, dy dx becomes 6 into -2 squared minus 6. 6 into 4 minus 6. 24 minus 6, that should be 18. 18 should be the gradient at that point. Find the s coordinates of the stationary point of this curve. At this stationary point, hence dy dx should be equal to 0. So we go to our dy dx as 6x squared minus 6. So 6x squared minus 6 to give us 0. Factorize 6 out. 6 into x squared minus 1 is 0. Hence, x squared minus 1 is 0. I can now write this as x squared minus 1 squared is 0. X minus 1 into x plus 1 is 0. Hence, x minus 1 is 0 or x plus 1 is 0. X equal to 1 or negative 1. Or I can read like this. X squared minus 1 is 0. X squared equal to 1. X equal to square root of 1. And root of positive number has two values. Plus or minus of x equal to minus 1 or 1. So put the values here, minus 1 or 1. So either way you get the same answer. So at this point we come to the end of this question. Thank you for listening. Stay tuned to our subsequent question. Click like and subscribe so that you can get all of our remaining videos for our qualitative improvement. Thank you very much. Have a nice day.
This is what we do in the masterclass, really. We try as much as possible to ensure that we're able to properly, right, teach learners how they can properly understand, interpret the question as much as possible. We dive deeper than just a past paper to ensure that at the end of the day, they're able to fully understand any question that is being administered to them.